From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 354, recorded live Thursday, January 10th, 2013. Support for Hansel Minutes is provided by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, training developers to work smarter. And now offering GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Brad Rittenhouse about malware on the web today.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and I've got Brad Rittenhouse from AVG Technologies. They're antivirus and internet security. And you're the AVG LinkScanner team lead.
That's correct. Thanks for having me on, Scott.
Thanks for hanging out. We actually met at Build and ended up talking for quite a long time about malware, and it's pretty scary out there right now, isn't it?
Well, the world changes every day when it comes to malware, and the bad guys are getting better, and so the good guys have to get better too. And it's a changing world all the time.
What do the bad guys want from me? Like, why do they want my computer?
Believe it or not, I think most people don't really consider themselves this, but every person is a commodity. And so the more information that the bad guys can get about you, if they can get your logins, if they can get especially your bank logins, then they can then turn around and sell those. So anything that can be made a commodity, someone is going to sell it.
So that brings up an interesting question in my mind that, you know how people they complain about Facebook, but they're not paying for Facebook.
Right.
And they always say, well, if you're not paying, then you are the product. Facebook is a big information miner. Would that mean that Facebook is really no different than any of these virus companies, except they just get their information because we hand it to them?
It all depends on what your use is, what your intent is, and what you want to do with that information too.
Right, but they sell that information. Facebook sells it to advertisers, which at least is somewhat noble, or maybe not noble, but somewhat American.
Right.
They're mining our information in a fairly anonymous way and saying, okay, white guys in Oregon like peanut butter or whatever, and that's valuable information. What are these malware writers doing? Do they want me personally, my information, like my social security number, or do they want it in aggregate?
I think they would get anything they can. But like everything else, the driving goal for these guys is money. They want to wipe out your bank account. They want to use your logins where you've logged into other websites and bought things. They want to use anything they can about you to generate money. And a lot of times, generating that money is simply selling your information to somebody else that is in some kind of a criminal activity.
Do they, are they like loners? Do you think that these are just like, I always imagine some 16-year-old Norwegian kid who's just writing an evil toolbar or some piece of malware just to be a jerk. But like, do you think that they hang out together? Do they have any sense of morality?
I think the world used to, that's the image that we've had in it, that it's some kids in their garages, what used to be called script kiddies, where they would download scripts and share these things online. Nowadays, it's a completely different world. It's an industry. It's commercialized malware nowadays. You can buy a toolkit to generate and distribute malware. So these are professional companies. They release versions of their tools that are put out, and they're QAing these things just like any other software company.
See, the idea of like a software company with like, 6 folks all go to work, they get up, they go to lunch together, they have like agile methodologies, source control. That is extremely disturbing.
It is, but the stakes are high. There's a lot of money to be made, and anytime there's money to be made, people are going to put together, and they're professionals at it, is where we are.
How do you guys categorize what I would think of as malware, which is truly evil software? And I don't know if there's a word for it yet, but, just shady software, that kind of software that just makes it just a little too hard to uninstall, like trickeries and things like that.
Right. It used to be, we had adware and things like that got pushed onto your machine, and it's just showing you ads.
Mm-hmm.
Nowadays, something we would consider malicious, it's anything. It's a gray area.
Mm-hmm.
You could say, well, just because it's annoying that it's malware, it's doing something in your machine, even though it may not be stealing your information. And then there's the other side that you know nothing about it. It's sitting on your machine. It's logging keystrokes and learning all it can about you and your logins and information online and how to get money out of you or steal your money.
Do you think that I should be more worried about JavaScript and websites and links that I might click? Or is it about native software that actually runs on my machine that's written in C by some person?
I think both of those are equally concerns for everyone. A native application that's going to be downloaded onto your machine obviously has a lot more control. It has a lot more power to affect you and to take down your machine if you want. JavaScript and cookies that are injected into pages, most binary malware gets on your machine through JavaScript. You hit a web page, and sometimes whenever there's what we would call a drive-by download, you go to a site, something gets downloaded to your machine, and it's binary and can do bad stuff. You didn't have to click on anything, but JavaScript is what was on the page being used in most cases to get that to you.
Interesting. So JavaScript is not only a way for them to collect stuff, but it's two things. JavaScript is a payload that could go and do things on its own, but it's also just a way to deliver a payload. So they can get you twice. They can collect everything that they could find on your browser and whatever cross-site scripting and cookie stuff that they do. And then when they're done, they can go and send something else down to cause trouble.
Right. And a lot of that, a big concern is with privacy these days and tracking cookies. And there's a lot more advanced methods of knowing which sites you go to and reporting that information back to various sites.
Do you guys have any relationships with the bad guys? I mean, I think of you kind of like as the police, and sometimes the police will have like informants and they'll have relationships with the bad guys and they'll meet them in shady places, like
confidential informant and CIs and things.
Yeah, I don't know. I'm just trying to get a sense of like who the players are. So if you're the good guys, like, do you ever like meet a bad guy?
I think you have to be you have to be in a gray area sometimes. Me personally, my team does not do the actual research on web threats, but we do work closely with them. Mm-hmm. And so in order to catch a bad guy, you kind of have to think like a bad guy. You have to know what they're doing. You have to know what tools are available, where they hang out, if there's underground kind of forums and things that they're on. You want to be on those. You want to know that information. And so if at all possible, then yes, then researchers are going to be in those areas to try and learn as much as they can.
Mm-hmm. And when you guys, in your product, AVG LinkScanner, is kind of a layer of security against web threats and hacked websites and things like that. When you've watched things evolve, do you start to notice like fingerprints and say like, oh yeah, this is so-and-so's exploit? I've been seeing that more and more as people have learned how he or she used that, and this kind of evolution of coding techniques.
Absolutely. Exploits, they evolve because it's a never-ending cycle. Bad guy puts out an exploit. Antivirus company comes up with a detection method for it. They detect it. That exploit gets changed. The malware gets changed. Everything is always changing so that something can be downloaded onto someone's machine and affect it in whatever way is intended.
Mm-hmm. There was a thing a couple of days ago on Hacker News about, I guess there's an exploit in a part of Rails. And when it kind of got discovered, the alert went out, and it was like, okay, there will be a proof of concept of this in the next 4 to 6 hours. So get ready. And they were going to put it in a thing called Metasploit. It's it's amazing. It's a suite of badness. You know what I mean?
That's correct.
Yeah. I mean,
the biggest one these days is called Black Hole. It's a Black Hole toolkit.
Uh-huh.
And it's an exploit and malware toolkit. It's I think it accounts for the last total like 65% of all malware out there that's being detected is somehow related to delivered with the Black Hole toolkit.
With the Black Hole, wow.
Mm-hmm.
And it's almost like they're not right. There are a flavor of script kiddie that is writing this software just by snapping it together from other pieces. Like they're not doing innovative and interesting new things. They're saying, I want a piece of this and a piece of that.
Right.
Like
it
Legos.
gets propagated more that way. But then again, you also have ones that they are coming up with something new. They are coming up with something that hasn't been seen before. And those are the bad ones, especially if you can hit a top website and you don't have to click anything and something gets onto your machine, then that's a big deal, and that becomes an enormous commodity in itself because you can track people, you can follow people, you can find out what they're doing.
How safe can people feel? Like I haven't had a virus in years, I think.
Right.
You know what I mean? Exactly.
Right.
I don't know if I don't have a keylogger right now.
Right, because a good virus, a good piece of malware, you don't know that it's sitting there. You don't know that it's reporting back. So that's why relying on security companies, security software, and everything like AVG is a suite. Security is built on layers. You have to, when you have a building, you don't just put a lock on the door. If it's a museum, you have a lock on the door. You have, electronic stuff, guards. There's a lot of different layers that you want to use in order to do security.
Do you, when we were talking at Build, you had some stories about particularly nasty experiences that you've had in finding these things. When the researchers bring an exploit to you, what are some, I guess I'm not sure what you're allowed to say and what you're not allowed to say. Is there anything you could talk about? You know what I'm saying?
Stories of big
stories of
things
fail
that have happened and interested.
Stories of fail, I think would be the way to phrase it, as my friend likes to say.
We had one, and I'm allowed to talk about it. It's on our website. I think it was blogged about, and you can read about it last August.
Mm-hmm.
And just to give you a little background, internally with antivirus, one of the big issues is because you have the power to block both network connections and delete files on someone's machine, just as the nature of the software. Mm-hmm. One of the big worries is about what's called false positives. So that's alerting on something that really isn't bad. And so we have a lot of mechanisms in place because if you do that and you push out something and everybody's machine detects this one thing that's really not bad, and you get alerts, it's bad press, it looks bad, and it also, you can denial of service your own servers with that because certain people, when you install AVG, you do have the ability to opt in to report whatever is found back to AVG. And so one of the big things we had last August, there was internally we started getting a massive amount of detections and hits and things being reported back to the servers. And at first we thought it was a false positive. We thought it wasn't actually real. Mm-hmm. But the detection that was being alerted on was a few days old, which mostly if it's a false positive, you'll get it immediately or within a short time frame. And so within about a 12-hour period, we had about 1.6 million detections, and it was detections on Facebook. And so people are kind of up in arms, and that's a huge deal. People are complaining, want to know how do you turn off this AVG because it's bad. What had actually happened was on Facebook, when you go on the sidebars, top, bottom, you have ads, and those ads are usually served up by what we would call ad rotators, mm-hmm. ad services, and in one of those, there was actually a black hole exploit had been injected into an ad. And so Facebook the ad had come from another company, and then the exploit itself had come from another company even from that, and gotten onto Facebook, and it was hitting people's machines, and LinkScanner was alerting everyone about it. But because there was so much of it, at first we thought it was a false positive and was like, okay, we might need to turn this off. We might need to get rid of it. But it just goes to show that, and in this case, you didn't have to click on anything. You didn't have to say anything. You didn't have to type anything. You went to the page and it hit. And we have a good relationship with Facebook, and luckily, they were able to take their things down on their side, and they're very diligent about security and getting back and taking care of that. But with a site like that, you can imagine it's an enormous problem. So
the speed at which it spread was so fast that of course, it must be a false positive.
Right.
It was far too successful.
Yes, it's only based on the number of detections. It wasn't really spreading. We figure we protected probably about 1.3 million people, but when it happens all at one time, that's a big load. And so, yeah, it just goes to show that Facebook is everybody considers it a safe site, but you never know.
Right.
I mean, it is, and they do a good job of watching out for it and protecting it. But when things like that happen, you still need software to be protected. And if these people hadn't have had AVG installed, they would have gotten infected.
It's funny. There's the software engineering kind of mantra of like, don't trust user input.
Yes.
And with Facebook, right? They trust themselves, but user input in that case would be the people that submitted the ads.
That's right.
Right. So,
and they don't have, they may not have full control over it, or even if they're running things to try to detect, is this a good or bad ad on their end? Maybe they don't, it's brand new. You don't have a way to detect it yet. And it gets through and it falls through the cracks.
Yeah. Not a malware thing, but kind of another example of not trusting user input. I guess that the Apple App Store recently shut down the ability to go in after the fact and change screenshots.
Yeah.
Because people were uploading stuff with one screenshot, getting okayed and put in the store based on that, and then sneaking in later and changing the screenshot. Because that was never that part of the submission process isn't checked.
Right.
That's really, really evil. These JavaScript things, I hear about JavaScript malware. Like I was pretty familiar and comfortable with how malware worked maybe 5-6 years ago. I haven't been thinking about JavaScript as a malware delivery thing. And I've been noticing a lot that you'll go to a website and then it'll be hacked. Or you'll get a note that says this site is infected and we're blacklisting it. And it's because some JavaScript that is known is on that machine. I know that MySQL, mysql.com famously got hacked in September 2011. How does that work? A piece of JavaScript somehow got onto the web server and then served from it? Or they hacked the homepage? I mean, how does that happen?
A web server is just a piece of software as well, and it's connected to the network, and people are able to access it. And so, like anything else, there can be an exploit on that web server, and somehow the bad guys are able to get JavaScript to be served up through web pages.
Mm-hmm.
We get our researchers get in a lot of ways act as technical support sometimes, because we have a lot of sites that come back at us and say, well, you're detecting me as bad, and I'm not. Somebody goes and looks at it, and they're like, hey, look, you've got this piece of JavaScript that's going out to some other place, and it's on your server. Here it is. It's proven. And what had happened was somehow somebody had injected this JavaScript onto their page, and it caused a hit to some other site. And so once you can initiate a server connection, then there's all kinds of ways that you can deliver some kind of a malware payload to someone.
I see. So it could be something as basic as they actually got a hold of the index.html or whatever served the initial homepage, right. But it could be they stuck it in a comment or in an ad, or
it would just anywhere that a JavaScript block of code is going to run, they can put that in.
It makes me wonder why.
They could put a new file up or whatever, and then have a link to it.
Yeah,
anything.
Makes me wonder why it doesn't happen more.
I mean, like everything else in the industry, everybody tries to patch flaws. Like IIS, flaws get patched whenever they're found, but it's always going to be software. It's always going to be written by people, and there's always going to be something that you're allowed to exploit.
If I were going to go to work at AVG and work on malware and JavaScript malware detection stuff, would you have me practice writing malware like in a lab environment?
We always say, honestly, I never worked in the security industry before I worked at AVG. I've worked there 5 years. Mm-hmm. And so I wasn't really familiar with it, but being around researchers, talking to researchers, the people that do this, hiring people is a really hard thing. Mm-hmm. Because it's part art, it's part technical knowledge, you can't really teach everyone to do it. So You have to find kind of the right kind of person that thinks that way, that has all these, crazy tools that they're able to put together and use, and watch what's coming off of websites, watch what, registry entries, files, everything that happens on a machine. They have to be able to interpret it and kind of figure that out, and they have to know how to go and find it. So there's some kind of social interaction there as well that, maybe they can get in or, act like they're a bad guy or whatever, but just to get in and talk to other people.
Mm-hmm. When you're writing a detector, I assume you're looking for some kind of hashes or some kind of fingerprint that indicates that this is the thing that you're looking for. Is that right? I mean, do you take a chunk of text and hash it up, or do you look for variable names? What are things that would tell you that something is malware? Once you've identified it, it's like, okay, I know this is bad. I need to go and find that everywhere.
So that's what you kind of reverse engineer what the exploit or malware is doing, what the delivery method is, and also what it's going to do when it gets on your machine. Mm-hmm. So you're reverse engineering that part. To detect it, yes, static of just looking at strings that are coming over the network, that's a simple method to do it with. But there's, like I said, with security, there's layers to it. So you do that, but you also do other things like heuristics. You do behavioral analysis. If your machine is connecting to a bunch of different servers that you've never been to before, that's probably going to be a bad thing. And so there's layers to that. You were asking about JavaScript earlier, and with that analysis, one thing that makes it difficult is that, especially black hole, we call it obfuscated JavaScript. Well, if you wrote a detection mm-hmm. that just looked for a certain string, and you put that out, well, the bad guys just have to change that string. Okay, that's fine. So you do a lot of different things in order to detect it, but the bad guys go one more step. They deliver JavaScript that actually gets randomized whenever the server serves it up to every different machine. And so in that, when it gets to your machine, the first thing the JavaScript does is it probably has some sort of a key in it, and then there's a block of text, it probably looks like base64 text, that a loop will run through, and it will unencrypt it on your machine that was randomized for your machine, and then it will run it.
Oh my.
So in that case, you can't really look for a certain string every time. Sometimes you have to look at the method that is going on behind the scenes.
Okay, wow. Because I was thinking, if there's so many ways that you could potentially have false positives. Like if you look for the wrong thing, you're going to find that thing potentially in perfectly reasonable code.
Right. If you find something that's Google Analytics JavaScript, that's on tons of web pages, and so you're going to start alerting on everything. Oh
my goodness. Okay. Wow. What is some trends that you're seeing in JavaScript malware? Are we headed? Is it kind of the same old, or are we on an upswing of new techniques? Because I know that everyone is obfuscating their stuff, and they're always looking for new ways to obfuscate it. So it's JavaScript within JavaScript within JavaScript. They'll use byte arrays of Unicode encoded bytes. That's just scripts within scripts within scripts. Like in the old days, they would just think of ways to mess up the script tag.
Right.
And now they just focus on how many nested layers, of inception can they make before the actual code itself gets executed. What kind of things are you seeing?
Well, like I said, I'm not on the front lines with that part of it, but the things that I'm aware of, a lot of it continues to be black hole type things where it's kind of a centralized development of the techniques, and then it's distributed mm-hmm. as a product. Where I don't know that there's a lot of really new techniques that are out there, mm-hmm. but then again, sometimes people publish that, this is sort of a kind of vulnerability with certain things, but then someone else gets ideas from it. Bad guys can see that and then push that out to something that could explode.
Right.
Everybody's always looking for that 0-day thing where they can push it out and it'll affect someone, some big site. That'll affect everyone that comes to it. And so that's what they're really looking for.
But don't most of these JavaScript exploits ultimately end in someone calling eval a couple of times? Like they'll go and they'll do. This is the thing about JavaScript; it's so dynamic. They'll write some code and they'll make it self modifying code, like you said. It's encrypted to you, and then it's decrypted, and then it's obfuscated. But ultimately, someone's going to call eval. Could we catch it at eval or stop allowing eval?
I mean, we could stopping, and well, like you would know, like you said, getting data from somewhere else and then just running it. Well, you never know what you're going to get. And so, yeah, if you just cut out eval, then, maybe that's what would happen. But there's a lot of different ways to get there.
Mm-hmm.
You could unescape. Basically, your escape, things come through escaped and stuff like that. You never know, what's going to happen with them. But it can get executed with a couple of different, ways that if it gets in a string and something's going to run it, then yes, it could be bad. And if that was all cut out, sure, it would work. But I think that also would probably cut down on a lot of the dynamic nature that JavaScript does allow websites to implement. It's going to cut down on certain features that you may be able to do.
Right.
I don't know that it's as simple as just, turn off eval and everything will be perfect.
That is the thing, right? The most secure machine is one that's not hooked up to the network.
Absolutely. One that's not turned on.
And yeah, exactly.
That's even more secure.
That is extremely secure. It's funny, I used to work in online banking, and some bank A was talking to some government agency B that was ultimately talking to some other bank C. I'm obfuscating, obviously, and extremely obfuscated because someone will know. But basically, it was one of these things where we had built this amazing, high-tech web service that would allow transfer of money from entity 1 to entity 2. And we had no idea that one of the steps in the process literally involved a guy named Joe taking a 3.5-inch floppy and taking a file from like a dump, like a batch off of one machine, turning around in his swivel chair and going to the other side of the room and putting it into another machine. You see what I'm saying? Like imagine had this kind of the Rube Goldbergian, like amazing bit of real-time web service technology that we created. And then it turned out like, why is it so slow today? Oh, well, Joe is out.
Joe needs another cup of coffee.
Yeah, Joe's not there. He'll catch up tomorrow.
You also want to make sure Joe knows the importance of his job too. If he just thinks it's a random thing and nobody cares, well, that's a big difference too.
Yeah, absolutely. Yeah, we could definitely make a very, very secure web. This is why I noticed more and more a lot of developers and kind of digerati, literati, are running without JavaScript enabled. Which I've always kind of thought was a little bit nuts, but you're starting to make me wonder if I should be doing that. I already run with FlashBlock.
Yeah, well, people use NoScript and a lot of these other things. There's,
I mean, how would I explain that to my dad?
That's right. Well, no, Dad, you can't click on this because we turned off JavaScript and none of your menu things work and nothing really fancy works. We stepped back in time on the functionality of a web page.
Yeah, I don't know the. Do you just surf regularly, or do you run without script?
No, I surf regularly with script.
And they're not concerned about it, because I have had comments of people, and I don't know if they're tinfoil hat people, but I've had comments on my blog of people saying, "Well, you're a fool to be surfing with JavaScript on. What are you insane? You're asking for trouble. They're going to
Yeah, I mean, I'm not a tinfoil head, so I surf with JavaScript on. I don't really worry about it that much, but then again, I'm not doing anything that they really feel, somebody's going to want, and then that's exactly my problem, right?
Right,
because
exactly.
we feel, I'm not doing anything I want. I think it's one of those things until you get bit in the foot that you didn't know. You're like, I should have been doing this. And that's education of users. It's education of people. I don't know that there is a good answer. I mean, you can't turn off your machine. Turning off JavaScript in a lot of websites, you can't do anything in it if you did. And so there's got to be some sort of something in the middle. Obviously, software that is watching out for you is one of the better solutions to that, because you get to function like you normally would. And then hopefully it's going to alert you whenever something bad happens. I think people, the education of people is some of the big things with it. People may think they're protected and they're not. They, And they don't go look out for it either. They're not searching for it.
How much of this, the people who get nailed are doing things they shouldn't be doing? Like when you scan links throughout the entire web, I mean, surely it must be the shady bits of the web that have the bigger problem. Like, I'm not going to get a major exploit. Well, you did mention the Facebook one, but I guess I'm saying if I'm running around on Russian, video game sites where I can steal software and torrents and things, that's the shady side of the web. Am I going to get nailed more there than I am at CNN.com?
Not necessarily. Because look at the numbers. Look how many people are going and trying to download a shady game from somewhere versus how many people are going to Facebook, or they're going to Google, or they're going to a big site. It's just the stakes are much higher on a normal site than they are at some underground site that only a few hundred people are ever going to hit. So it's where you want to put your energy and where the bad guys want to put their energy, and the target is much bigger on bigger sites. And so it's always... that's always the goal. Look at YouTube. YouTube's using a lot of scripting, and there's been some issues with it. So
I see. So they might be using the shady sites as a practice run, but you're right. The real money, I suppose, the people with money and the people who we want would be, like I say, my mom and dad, and they're going to get them at CNN.com and places like that.
Right. That's right. You want the biggest number of people, biggest bang for the buck. So if you can exploit a big site, get a lot of information, then that's where they want to be.
Oh man, that's just evil. I don't know. I still would have a real emotional problem with like sitting down and writing software for the discrete purpose of hurting people. You know what I mean?
I guess there's people that they may not care about that part. They care about I'm making money. And these days, like I said, it's organized. It's like organized crime, but it's organized software. It's organized cyber criminals. And they're piecing everything together. If they find, there's reports where a botnet, so whoever's in charge of a botnet or something like that, that's receiving a lot of this information, you have to think, okay, once my machine's compromised, what happens to the data if it gets sent to someone? There's a market. There's markets where people put up websites and you can buy your login to Amazon or whatever other sites that you're going to. Even your bank account. If there's a bank account connected, it's probably costs more. But you can buy a personal, access to someone for $2, $5.
Right.
And if they millions of those people, then that's their income.
I wonder if I need to go and buy back the access to myself. How much that would cost.
That would be the best. That would be a great market right there. So you can go and look and buy back my information.
Yeah. Well, Brad Rittenhouse, thanks a lot for chatting with me today.
I appreciate it, Scott. Thank you for having me on.
Again, Brad is a team lead on AVG LinkScanner. You can go and Google and find that. And this has been another episode of Hansel Minutes. We'll see you again next week.